We used to call it as fridge in our daily life. Refrigerator and heat pump, both are the devices worked on reversed heating. Okay, so let us say we can say refrigerator first, right? So what is this one? This is the sink under temperature T2, and this is the source under temperature T1. Okay, right. So what is the main working of refrigerator? What refrigerator will do generally? So if let us assume this is our refrigerator in our home. Inside this refrigerator we have the freezer. Okay, here we have a knob, or we can say thermostat, to control the temperature, right? So now if you see, there will be one coil will be submerged in the refrigerator, one pipe, let us say, that it is inside the we call freezer. Okay, that is nothing but thermostat end. Okay, that will sense the temperature inside the refrigerator. Based on that, it will give signals to the compressor, whether compressor has to start or stop, depends on the temperature adjusted by the thermostat. Okay, now inside we have different racks, we can say, right? So let us say we will buy the goods from the market, right? And we will keep inside the refrigerator. We'll keep inside the refrigerator. What it will do? Tell me. What it will do? What will happen after some time? Right. So the temperature at which we will keep the goods will room temperature. But after some time, what will happen? This temperature is keeps on decreasing, and let us say 5 degrees or 6 degrees, the temperature will be maintained in order to store the food for long time. That is the main purpose of refrigerator, right? Means here outside we have atmospheric temperature. So outside the refrigerator we have atmospheric temperature, let us say 27 degrees centigrade. Let us assume summer. Okay, now inside the temperature is let us say 5 degree. How 5 degree is achieved? The moment you keep inside the refrigerator, the temperature will be 27 degree, and it's keep on decreasing, right? Means what refrigerator will do? It will extract, let us say, when the temperature inside the fridge is, let us say 20 degree. 20 degree is less than 27 degrees centigrade, right? Now means it always extract the heat. Try to understand. It always extract the heat from your body under lower temperature, and it will reject heat to the body under high temperature. That is the main purpose of the refrigerator. Means refrigerator works between body under lower temperature and to the other body under high temperature. It always works between the body which is under lower temperature, and one more thing is under high temperature. It always extracts the heat from the body under lower temperature and reject it to the body under high temperature. This is the Q. Clear? It will remove the heat from the body under lower temperature, and it will supply to the body under high temperature. Yes or no?
Yes, sir.
Right. Means here the sink is under lower temperature, means this is my refrigerator. Got it? This is my refrigerator, and the source is under high temperature. This is my atmosphere. This is the atmosphere. Agree? Right? So this is under lower temperature, this is under higher temperature, right? So in order to remove the heat from the bodies, what we are doing, we are supplying certain work, that is by using compressor. So let us say this is the work supplied to the refrigerator, right? Therefore it will extract Q2 from the sink, nothing but your refrigerator, and supplies Q1 to the atmosphere. Is this figure is clear? Any doubt in this figure? Right, this Q2 is my effect, my required effect. This is required effect. I can call it as refrigeration effect. This is the refrigeration effect. Okay, right. So I think this figure is clear. Why I am supplying the work? Because we are taking the heat from the body under lower temperature and we are supplying to the body under high temperature, right? So if you see, naturally always heat will flow from body under high temperature. This is a spontaneous process, high temperature to the lower temperature without any addition of heat or something, any work, right? Always the property of the heat is it will flow from body under high temperature to the body under lower temperature. This is possible without any external aid. But if you want to do in the reverse manner, if you want to supply the heat from lower temperature to high temperature, for that you supply some work. That is the reason W is the work done on the refrigerator. W is the work done on the refrigerator in order to extract the heat from body under lower temperature and to supply to the high temperature, right? So the performance of refrigerator or heat pump is evaluated by using the parameter COP. It is called coefficient of performance. It's like efficiency only. It is called coefficient of performance. So that is equals to what is the output we required? What is the output we are get required from this refrigerator? The refrigerating effect, refrigeration effect by, for that what we are supplying input, that is the work input. So this is the COP. Okay. Now if you write the energy balance equation for refrigerator, tell me, if you write the energy balance equation for the refrigerator, W is going inside and Q2 is also going inside and Q1 is coming out. So therefore, work is equals to Q1 minus Q2. What is the refrigeration effect? What is the requirement here? My requirement is to remove the heat to maintain the coolness. That is the Q2 is my refrigeration effect divided by Q1 minus Q2 is the heat supplied. This is the COP of the refrigerator. And one more thing, we have heat pump, that is also works on reverse heat engine, right? So where we will use heat pumps we will use in cold countries to keep the room warmer. Okay, so it is also works on reverse heat engine. Let us say this is the heat pump. It will extract the heat from body under lower temperature. Let us say now this is the body under high temperature. This is my source at temperature T1 and the sink at temperature T2. This is a reverse operation, therefore upward direction. One second. Right now, so here heat pump, what it will do, how it will work, we will see. Now let us assume, sorry, right, let us assume this is my room and assume that it is same winter season. It is winter season, we are in room, right? So let us say, what is the room atmospheric temperature in winter? Let us say during night time, let us say it will be 12 degrees centigrade. At what temperature human body is comfortable? Anyone please tell me? What is the comfortable temperature for human body?
37 degrees.
37 degrees is comfortable.
32, sir.
27, 28, 29, 30. Yeah, 30 approximately. Depends on the, our power. Okay. Now let us say we need to maintain, let us say 27 degrees. Let us say 27 to 30 we need to maintain. If we maintain 27 to 30 degrees centigrade, we feel comfortable. Okay, but if you see outside, the temperature is, if you see outside, the temperature is 12 degrees centigrade, right? Now if you heat the room, then only, now if atmospheric temperature is 12 degrees centigrade, inside the room also we will be having 12 degrees centigrade, yes or no? Maybe 1 degree more than that if you close all the things. Okay, now 1 degree more than that, right? But I want to maintain 27 degrees centigrade, therefore I need to install one heater inside the room. Agree? We are using heaters nowadays, right? Now if you use the heater, what will happen? Right, so what it will do, it will extract the heat from the atmosphere. Observe carefully. It will extract the heat from the atmosphere and it will add to the room. The heat flow will be like this. So what is the temperature of the atmosphere? Now let us say in this process, what will happen? This 12 degrees crosses and it may go 15, 16, 17 like that. Like that it will go to 27, 30. Let us assume at an instant of time inside the room we have 16 degrees centigrade. Now outside the temperature is 12 degrees centigrade. Which temperature is lower? The atmospheric temperature is lower. Still the heater is extracting heat from the body under lower temperature. See, observe here. The heat pump will work like this. It extract the heat from the body under lower temperature. What is the lower temperature body? Lower temperature body is our atmosphere. It will extract the heat from the body under lower temperature and it add to the heat body under high temperature. Our room is under higher temperature. That is the main working of heat pump. Means heat pump will work between the body under two temperatures, right? No, body under high. Sorry, it works between room and the atmosphere. It is the higher temperature body and body under lower temperature. Whereas coming to the refrigerator, it works under lower temperature and surrounding is under higher temperature. Here system is under higher temperature, surrounding is under lower temperature. Here refrigerator is my system and this is my surrounding. System is under lower temperature, surrounding is under higher temperature. Whereas here system is under higher temperature, surrounding is under lower temperature. Okay. Now if you come here, now which is my room here? Tell me, anyone, regular students. We said that always room is higher temperature body, atmospheric pressure is under lower temperature body. So which is our room here? Which is our atmosphere here? You should
Source.
answer after listening the story. So very good. Source is our room. Very good. And sink is our atmosphere.
Atmosphere.
Yeah, sink is the atmosphere, right? So in order to do the process reverse, we need to supply the work. This is the work. This is the heat pump. Okay. Now it extracts the heat from body under lower temperature and it supplies the heat to the body under high temperature. Let us say Q1 and Q2. Okay. If you write the energy balance, so what is going in is W plus Q2 and out is equals to Q1. So therefore W is equals to Q1 minus Q2. W is equals to Q1 minus Q2, right? Now, as I told, the efficiency of heat pump or refrigerator is generated by COP. COP is equals to what effect? What is the effect here required? This is our required effect. Yes or no? This is my required effect. Means heating the room is my requirement. So that is the Q1 is the required effect. So required effect by what is the supplied? Okay, required effect is Q1 and what is the work here? Q1 minus Q2. This is the COP of pump and this is the COP of refrigerator. Okay, this is the COP of the refrigerator. Clear now? Right. So if you write two at a time, so we can evaluate the relation between the pump and refrigerator. COP of a pump is equals to, so refrigerator is equals to Q2 by Q1 minus Q2 and COP of pump is equals to Q1 by Q1 minus Q2, right? If you add 1 to the refrigerator, 1 plus COP of refrigerator, so what you will get if you add 1 to this one, so you will get Q1 by Q1 minus Q2 if you do LCM. So nothing but this is the COP of the pump, means always COP of pump is greater than COP of the refrigerator. That is how much amount it is the equal to 1. This is the relation between COP of pump and refrigerator. Therefore pump COP is equals to refrigerator COP plus 1. Clear? Till that we discussed in the first class. If it is okay, then I will continue with the regular class. Any doubt, please ask me. We discussed the heat engine, refrigerator and heat pump. Okay, right? Students,
Yes, sir. Continue.
right. Yeah, now I'll continue regular class. Right. This is what I discussed just now. Just go through quickly. Just I will go through this. This is the thermal reservoir, that is source and sink. Source is higher temperature, sink is under lower temperature. Okay. Just this I just for understanding sake, higher temperature I shown with red color and lower temperature I show with the green color. Let me take the pen. Okay, right. So source is this one and sink is this one. Then refrigerator. So as I discussed, refrigerator operates between temperature of surroundings and temperature below the surrounding. Below the surrounding is your refrigerator area, and surroundings means your atmosphere and less than atmosphere. Similarly, heat pump operates between temperature of surroundings and temperature higher than the surroundings. Higher than the surrounding is your room, and surrounding is your atmosphere. Okay. Now, so refrigerator and heat pump both are working in the reverse of heat engine, and COP is the desired effect to the work input. Okay, so COP of pump we calculated Q2 by Q1 minus Q2, sorry, Q1 by Q1 minus Q2, and refrigerator is Q2 by Q1 minus Q2. This is the relation. Pump is equals to 1 plus refrigerator. Okay, now we will solve the problem. Okay, so a heat engine. So we have heat engine. So just draw the heat engine. It is the temperature T1. That is the source. It extracts Q1 amount of heat, and some amount of heat will be converted. That is Q1 minus Q2, and the remaining it will reject it to the sink under lower temperature. Right. Whenever heat engine problem comes, you should draw this diagram. Okay. So Q1 is the heat supplied, it under high temperature, and Q2 is the heat rejected to the sink under lower temperature. W equal to Q1 minus Q2. That is the work done by the heat engine. Okay, that produces work equivalent. W is given, so W is equals to Q1 minus Q2, that is equals to 80 kilowatt is given, and with an efficiency is equals to what? Work done Q1 minus Q2 by heat supplied Q1 is equals to 40%. 40% means it is 0.4. Determine the heat transfer rate to and from the working fluid. What he is asking, tell me. Determine the heat transfer rate to and from the working fluid. He is asking Q1 and Q2. From Q1 value and Q2 value he is asking. What is the working fluid here? This is the working fluid, right? What is the heat transfer rate from as well as to the working fluid? Q1, Q2, right? So if you substitute directly Q1, Q2 value is given, and Q1 is equals to Q1 minus Q2 is 80 kilowatt. Right now, so it is kilowatt divided by 0.4. So this is equivalent to 200 kilowatt. That is the Q1. Okay, and if you know Q1 minus Q2 is 80. Q1 minus Q2 is equals to 80, and Q2 is equals to Q1 minus 80. That is equals to 200 minus 80. That is equals to 120 kilowatt. So total Q1 is equals to 200 we supplied, and from that we are getting 80 as the work. Remaining 120 is rejected to the sink. These are all kilowatt, nothing but kilojoules per second of heat. This is kilojoules per second of work. Clear? Very simple basic problem, just to understand the terminology. Work is given, efficiency is given. Can I move to next problem?
Yes, sir.
Diploma people.
Yes, sir.
Okay. Right. Next problem. A heat engine develops, same figure will apply here also. Q1 is the supply, Q2 is the rejected. Develops 10 kilowatt power. Work is given. W is equals to 10 kilowatt, and receiving heat at the rate of, receiving means it is Q1. Q1 is equals to 2250 kilojoule per minute. Evaluate the corresponding rate of heat rejection from the engine at its thermal efficiency. So asking what is the value of Q2 and thermal efficiency. Thermal efficiency is Q1 minus Q2 by Q1. That is the heat engine. Okay. Now, so what is work? Work is nothing but Q1 minus Q2. But here the thing is, the work is in kilowatts, but heat supplied is in kilojoules per second. Are the units are balanced here? We should balance the units, right? So kilowatt is nothing but kilojoules per second, right? Now, so here also we should convert kilojoules per second. So for that 2250 divided by 60, therefore minute is converted into second, kilojoules per second. Okay, therefore it will become kilowatt. Okay. Now tell me what is this value? If you simplify, you will get something. Okay, now I am writing 225 by 6 kilowatt. Therefore, Q1 minus Q2 is equals to given 10, and Q1 is here. Q2 is equals to Q1 minus 10. That is equals to 225 by 6 minus 10. How much it will be? 225 minus 60 by 6. 165 by 6. 6 2 0. 27.5 kilojoules per. Correct? Huh?
Yes, sir.
Is this is correct?
Yes, sir.
Yeah, Q2 we got. Once you know Q2, what is the required thermal efficiency? Thermal efficiency is equals to Q1. Q1 is Q1 minus Q2 is 10. It's already known. Q1 minus Q2 is 10. That is the work done by Q1. Q1 is equals to it's applied. That value, how much here? This is Q1. So this is equals to 6 3 is 18, 37.5 kilowatt. 37.5 kilowatt into 100. So if you simplify, you will get the efficiency. Clear this problem? Understanding the problem is important, right? For every question, you might have used work done W equal to Q1 minus Q2 and efficiency W by Q1. Q1 is the heat supply. The thing is, you should balance the units. Units balance is very, very important, right? Otherwise, you'll get wrong value, because all the units should be in SI units. SI unit for the work is the strictly speaking joules here, but it is the ratio. That is the reason I'm using directly kilojoules per second, or else the SI unit for the heat is joule only. It's not kilojoule. Joule is the SI unit, or it may be Newton meter, Clear this one? Let me go to the next one. Right. A reversed heat engine. Yes, reversed heat engine means it may be either pump or refrigerator. Let me write P oblique R, pump or refrigerator. First draw the figure. It will extract the heat from the body under lower temperature T2. It will supply to the body under high temperature Q1 and for that it requires work. W is equals to Q1 minus Q2. It's line circle. W is equals to Q1 minus Q2. Right now, just go through the question once, all of you. Tell me what is the data given, what is the required. Right. So it absorbs 250 kilojoules of heat. What is that value, Q1 or Q2? I want answer from you.
Q2.
Q2, very good. It is absorbing, very good. Q2 is given. Q2 is equals to 250 kilojoules and low temperature region, and has a mechanical input, that is W input, because it is a reversed engine. We need to supply the heat. Q1 minus Q2 is equals to 100 kilojoule. What would be the heat transfer to the higher temperature region? What he is asking? What he is asking? What is the heat transfer to the higher temperature region? This is Q1 he is asking. Agree? He is asking Q1, yes. Right? So we know Q1 minus Q2. Yeah, Q1 is equals to 100 plus Q2. That is equals to 350 kilojoules is the heat transfer rate to the higher temperature region. Also evaluate COP of the reversed engine when working as a refrigerator and when working as a heat pump. Whenever it is working as a refrigerator, so COP of refrigerator is equals to desired effect is Q2 divided by Q1 minus Q2. And COP of, once you know refrigerator, we can calculate, or simply I can add 1 plus 1 to the COP of the pump. Anything we can do, yes or no? So Q2 is equals to 250 divided by 100. So that is 2.5. I forgot to inform, always COP should be greater than 1. COP should be greater than 1. This is a refrigerator, and for pump it will be 1 plus 2.5. Even if you calculate also, you'll get 3.5, because COP of pump is equals to this is equals to Q1 by Q1 minus Q2. So Q1 here is 350 divided by 100. So that is equals to 3.5. Clear this problem? Please respond. Is the problem is clear?
Yes, sir.
Yes, sir. Clear.
Right.
Yes, sir.
Okay. So then we will stop this one with this, and next class I will start Kelvin Planck's and Clausius statement, exact second law of thermodynamics. Okay. Right. So inform to your students very less attendance.